Hello, today I'll be talking about Chapter 5 of the Data Management Body of Knowledge. Chapter 5 is called Data Modeling and Design. So I'll start off with data modeling. So data modeling is an important part of effective data management, and it includes the discovery, analysis, and representation of data requirements through various different schemas. There's 6 main schemas. Those are relational, dimensional, object-oriented, fact-based, time-based, and NoSQL. These data models can be conceptual, and they can exist from a physical or a logical level, and they serve as communication tools. They can be business-wide vocabulary, and they can be guiding applications. So the goals for these data models can be confirming understanding, aligning with business needs, supporting initiatives, and decreasing the cost to the business. An example of this could be the company that I work for, which is actually the government, the city of Indianapolis, where we're wanting to increase our security posture. In order to do that, we would need to use data modeling for like the propagation of malware, the like our track of security events, the track of vulnerabilities, the track of our access controls that we have set in place, and also keeping track of finances. In order to request more money, we have to have more proof of like the issues that are going on. So if we have good data models, we can have good ways to show diagrams of these are the threats, these are what's going on with our systems, these are how we're preventing them, and we can show that to business people that would have a better idea, because models are a lot easier for them to understand than the generic terms that we use that can get really complicated. The text goes on to talk about different data modeling tools, which can range from simple ones that are used for just drawing functions, all the way to more advanced ones that can be used for forward and reverse engineering. The text also talks about lineage tools, which can go through the source structure of attributes, and which can allow us to do impact analysis across the systems. And then it talks about data profiling, where data is used to uncover insights, identify quality issues, and notice any anomalies for analysis later on. The book goes on to talk about ISO 11179, which talks about naming attributes and writing definitions. It talks about the benefits of those. It also talks about the collaboration between data modeling and data design structures, and it talks about the benefits of that, which include increased security, increased reusability, increased integrity, and prioritizing maintainability. The text goes on to talk about the relationship between data analysts, designers, and the consumers. And it talks about how your short-term needs should be lined up with your long-term interests. And in order to get to that point, it recommends that you have naming standards for your data, have the methods defined, have your roles defined, and consider what metadata you have before moving forward. It also says that you should review your designs, do software version management, and use something called a data model scorecard, which can be used to assess where you're at versus enterprise standards. In conclusion, data modeling and design are extremely important if you're wanting to move forward with data management. Whether you're wanting to tackle your cybersecurity needs, make sure you're keeping up with your business standards, or just making sure that you have collaborative efforts between your teams. Because if you have a good way to view your data, then that's how you can present it to the business people that are really in charge of keeping your business afloat. And that is how you can have an extremely robust data ecosystem. Thank you for listening.